In terms of the sort of overall problem space that you're tackling, you mentioned that one of the problems is being able to allow non-engineers to access and ask questions of the data that exists within the organization. And I'm wondering how you are approaching that problem, some of the scope of the problem that you're taking on at Nexla, and some of the ways that Nexla might integrate into an existing data platform.
Sure. So when we pose the question, how can data be used by more people and in more applications, then it led us to four core problems that we felt had to be solved. Okay. First, and as I said, we wanted the non-technical user to be able to do this. So that led us to four key problems. First was that we had to break through this connector barrier. And there's so many systems to connect to, so many formats, different velocities of data. How can we connect to new data systems without having to go and write and create new connectors? So that led to a piece of our technology which we call as a universal connector. We can talk more about that. So that was one problem. The other problem was that once we can connect to the data, how do we present to the user in a way that they can understand? And that led to the concept of nextsets as a logical data unit, something that is consistent no matter where the data comes from, right? Then the other problem that we also looked at, as I mentioned, we were also thinking about data that's going between companies and their ecosystem of their customers, their partners, their vendors, and so on. So we thought that if data has to move across companies, it will have to move across clouds, it will have to move across on-prem to cloud, and therefore the architecture should be such that it can support those scenarios, right? And then the fourth thing, we felt that, we want the data user, the person who understands the data, to be empowered, but data challenges are very diverse. So we will need to have a way to collaborate. So one of the other problems was collaboration. Collaboration all the way from someone who is an expert in the data to someone who is an expert in the data system. And then, and that led to the concept of no-code capabilities in Nexla, to the low-code capabilities, and the full-on developer platform, which has APIs and SDK and CLIs and everything.
As far as somebody who has an existing data platform and they're looking to be able to simplify some of their data operations and take advantage of what you're building at Nexla, what are some of the components of a sort of common data stack that somebody might replace with Nexla? So I'm thinking in terms of maybe like the open source components that people are familiar with, such as Spark or Kafka or the data warehouse, or just sort of where Nexla sits in that overall domain.
At a very high level, I would say when it comes to technologies like Kafka, Spark, and so on, we don't replace them. We actually make them more usable by people, more easily adopted. There's sort of four sort of things that we solve for companies, right? One is the integration aspect, which is multimodal integration with ELT integration, ETL, reverse ETL, streaming integration, API integration. So we look at all these four modes of integration, and we present a solution for that, something that can be done in a user interface, click through, and so on. When the actual execution happens, we leverage, or we are able to leverage some of these technologies as appropriate, like Kafka or Spark or some of our homegrown engines as well. So in that way, we can sit on top of or benefit from the tech you already have or the know-how you have, but make it more accessible to more users. By the way, I would note that we never think of it as a replacement. Whenever it comes to technology, especially in data, there's so many problems that are coming that are new. That's not usually go back and rip and replace things. It's more about solving the new problems, right? So integration is one part. The other part is the preparation of data. How do we transform, enrich, filter, validate the data so that it becomes ready to use? Integration means just reading or writing it. So preparation is the next part of that. Since we are in the flow of data, we do enable error management, data quarantine, notifications, alerting as far as the flow of data is concerned and what we expect from that. And then, the fourth piece that we touch in addition to integration, preparation, and monitoring is the discovery. We sort of auto-generate a catalog from our nextsets that we'll talk about, where users can find, hey, where's the data I'm looking for? Is this the right one? And then, access and use it.
And a point to add here is, these are all pluggable components. So it's not that you want to use the entire thing. You can sort of choose to use a part of this. For example, if you already have written some code in Python, but you don't have the integration layer to where you want to fetch this data from, or you have a new integration layer that you want to fetch data from, you could use Nexla for the integration piece, but you could use your pre-written transformations in Python to transform your data and then push it out. Similarly, if you have a new customer requirement who wants to move from GCP to Azure, you have all the logic that you want on GCP, but you don't have a Synapse connector. You can probably use Nexla to just push data to Synapse, again, which is you use your existing thing, but you're able to get the additive thing from Nexla in a matter of 2 or 3 clicks.
So we have very much been used with existing monitoring systems, with existing catalog systems, where we end up supplementing them or feeding information into those tools and make them more capable.